This is the brief on scalar and vector integrals in symmetric systems. We're going to quickly break down a fundamental idea in fluid dynamics. It's kind of wild. How can something have a ton of energy from its internal motion, but, zero overall movement? It all comes down to how we sum things up with integration. Okay, first, we've got to distinguish between scalar and vector quantities. So when you're looking at a fluid, its total kinetic energy is a scalar. Just think of it as a simple number that measures the sheer magnitude of all that motion. But then you have total linear momentum. That's a vector, which means it has both magnitude and direction. It cares about where things are going. Second, symmetry just changes everything, right? In a perfectly symmetric system, like a fluid vortex spinning evenly, all that super vigorous internal motion doesn't mean the whole system is actually going anywhere. And finally, here's where it gets cool. This is the paradox of it all. That total kinetic energy, the scalar, is huge and non-zero because all that motion adds up. But the total linear momentum, the vector, it's basically zero. So why is that? Well, for every bit of momentum going one way, there's an equal bit going the exact opposite way on the other side. They just cancel each other out completely. Energy always sums up, but symmetric vector fields can cancel out.